Your AC is suffocating, and the part that is quietly destroying its performance costs $8. Not a recharge, not a new compressor, not a $400 diagnostic at your dealer, just $8. Right now, the air coming out of your vents is likely 10 to 20% warmer than it should be, and that is not an exaggeration. That is pure physics working against restricted airflow. Hidden behind your glove box is a simple component that controls the breathing of your entire HVAC system. And when it becomes clogged, everything starts to fail in a way that feels expensive but is actually incredibly simple to fix. This is the detail the automotive industry has been counting on you never discovering. Because once you understand it, you will never fall for unnecessary AC repairs again. Back in 1954, a company called Nippon DENSO was established and spun off from Toyota Motor Corporation with a single purpose: to engineer thermal and HVAC systems that would define automotive efficiency for decades. That company evolved into DENSO, a global supplier operating across dozens of countries. And today, the same engineering still sits inside millions of vehicles. When a cabin air filter is purchased from a dealership with a branded label, there's a strong chance the part inside is manufactured by the same source that produces identical filters sold elsewhere for $7 to $8. Yet dealerships routinely charge $28 to $40 for the exact same component, built with the same materials, the same activated carbon layer, and the same multi-layer construction. The difference is not engineering or performance. The difference is packaging, and that is where the markup lives. Activated carbon is the core of this technology, and it is far more advanced than ordinary charcoal. It is created by exposing carbon material to extreme heat, typically between 600 and 1200 tortigrrs in an oxygen-controlled environment. This process forms a network of microscopic pores that create massive internal surface area, allowing contaminants to chemically attach themselves to the surface. As air passes through, harmful compounds like exhaust gases, nitrogen dioxide, ozone, and odor molecules become trapped. This process does not dissolve contaminants, it binds them permanently. Under controlled conditions, filtration systems using activated carbon have demonstrated the ability to remove up to 90% of airborne contaminants inside enclosed environments. But filtration is only half the story. The other half, the part almost nobody talks about, is airflow. The cabin air filter is not just cleaning air. It is the primary pathway that every bit of air must pass through before reaching the cabin. Every cubic foot pushed by the blower motor goes through that filter, whether the system is heating, cooling, or defrosting. When the filter becomes clogged, the blower motor is no longer pushing air freely, it is forcing it through resistance. The evaporator, which is responsible for removing heat from the air, cannot operate at full capacity because it is not receiving sufficient airflow. The refrigerant continues to absorb heat, the system continues running, but the cooled air never reaches you effectively. This creates the illusion of a failing AC system. The vents feel weak, the cabin stays warm, and the system runs longer cycles trying to compensate. In broader HVAC studies, restricted filters have been shown to increase energy consumption by up to 15%, and when applied to a compact automotive system with high-speed airflow and limited space, the impact can feel even more severe. The system is not broken, it is being suffocated. In real-world applications, this small oversight has led to massive unnecessary expenses. In one case, a fleet of vehicles experienced repeated compressor failures over a short period, leading to costly repairs ranging from $800 to $100 per replacement. After investigation, the root cause was not defective compressors, but neglected cabin filters that had not been replaced for extended periods. The restricted airflow forced the system to operate under stress, increasing electrical load and causing irregular compressor behavior. Once a simple replacement schedule was implemented, the failures stopped completely. The solution was not a major repair, it was the same $8 component that had been ignored. This pattern exists because of how the maintenance industry operates. A vehicle blowing warm air often leads to a chain of services, starting with a refrigerant recharge at $150, followed by inspections at $200 and diagnostics at $120. By the time the real issue is discovered, the total cost can easily reach $470, all while the actual fix remains a clogged filter worth $8. This is not about deception, it is about incentive. Complex repairs generate revenue, simple fixes do not. Replacing the filter is straightforward and requires no special tools. The glove box is opened, its sides pressed inward to release the stops, allowing it to drop forward. Behind it sits a small rectangular housing that contains the filter. The cover is released, the old filter is slid out, and its condition becomes immediately obvious. Most are dark, clogged, and filled with debris that has been restricting airflow for months. A new filter is inserted in the same direction, the housing is closed, and the glove box is secured back into place. The entire process takes 4 to 6 minutes. Once replaced, the improvement is immediate. Airflow returns to normal, cooling becomes stronger, and the system begins operating as designed. The evaporator can now transfer heat efficiently, restoring the temperature difference that determines how cold the air feels at the vents. At full airflow, this difference can reach 18 to 25 degrees, delivering the sharp cooling effect that many drivers assume their vehicle has lost permanently. However, the effectiveness of the filter is not permanent. The activated carbon layer has a limited capacity and does not regenerate once saturated. After 12,000 to 15,000 miles, it loses its ability to trap gases, even if the filter still appears functional. In polluted environments or heavy traffic conditions, this lifespan can be even shorter. Continuing to use a saturated filter reduces air quality, weakens cooling performance, and increases strain on the entire system. Ignoring this small component has long-term consequences. Reduced airflow leads to moisture buildup, which can cause mold growth in the evaporator. The blower motor works harder, increasing wear, and the compressor cycles more frequently, raising the risk of failure. All of this begins with a simple restriction that could have been eliminated in minutes. The cost of replacing the filter annually is $8, while the cost of ignoring it can escalate to $300 to $600 for mold treatment and significantly more for mechanical repairs. The difference between a car that delivers instant cold air on a hot afternoon and one that struggles to cool down often comes down to this single overlooked part. The system was engineered to operate at a specific airflow level, and when that airflow is restored, everything else falls back into place. The performance you thought was gone was never lost, it was blocked. That $8 filter is not just a maintenance item, it is the key to restoring your AC system to its original efficiency. It is the reason some vehicles cool instantly while others struggle under the same conditions. It is the simplest fix with the biggest impact, and once understood, it changes how every cooling issue is approached. The system was designed correctly from the start, and the only thing standing between you and that performance is a small, replaceable part hidden in plain sight.